Hello, good afternoon, folks. Thank you for joining this webinar. Yeah, we have a pretty strong content for you today in product design collection. I'll introduce the next speaker who will take you through this today. We have Kirti, he's our technical specialist, and he's going to talk about the product and how do you get into the details. So we'll have a Q&A session as well. So I really encourage you to write down all your questions. We'll be happy to answer at the end of it. But I really want to emphasize that now, as you know, we moved into the subscription model, and we really encourage you could be a product designer in a company, or you're looking at. I think the subscription model, the model that we have for all of you, allows this product to be used when you want it, where you want it. But it's all how do you want to use it? That's what we'll discuss here. How are the product usages and what are the areas it covers? So pretty excited what we have in content. So with that introduction, I turn it over to Kirti. Kirti Malaviru is going to speak. Kirti, over to you.
Thanks, Ajit. Good afternoon, everyone. My name is Kirti Malavuru. I'm the Technical Solution Manager at Autodesk, looking at the manufacturing set of solutions. First of all, let me all welcome you to this webinar. So this is a pretty exciting stuff, that we are doing. That is with our new product line, that is Product Design Collection, which was introduced somewhere at the mid of last year. So now, before I begin, let me give you a gist of what Product Design Collection is all about. So Product Design Collection, as the name suggests, it's a collection of different set of tools and technologies which can help you to cover, or which can help you to achieve your entire engineering workflows end to end in a product life cycle. It provides you with the all set of right tools, connects across different platforms to achieve interconnected workflows, and also provides a leeway for you to prepare for the future with a lot of things and a lot of new technologies that are cloud enabled as well. So as I said, Product Design Collection provides you with a set of tools which can help you integrate your workflows across various engineering disciplines, right from your 2D to 3D, 3D to project reviewing, 3D to analysis, 3D to your animation, visualization, and as well as also help you to create a complete understanding of your factory utilization or factory management as well. So what basically Product Design Collection aims at is to attain a very, very tight digital prototyping solution, right from creating your concept design to all the other engineering aspects involved around it, like your creating your 2D, creating your 3D. In 3D, it could be your modeling, then connecting with your sheet metal, your frames, your tubing and piping. It could also be connecting with the electrical workflow, doing your tooling, molding and tooling, automating your design, creating a layout for your entire factory, understanding how things are working in a factory, how it is constructed, how I can optimize the entire workflow, and finally also help you to prepare documentation, technical publication, as well as marketing content in the form of imagery or videos. So if you see this slide, product design collection provides you with a tight integrated digital prototyping model which will help you to achieve all the engineering workflows that are there in a single product entity. So as I was saying, the way it is done is by a very, very tight, integrated and an interconnected workflow. Just hold on for a minute. It seems that a couple of people are not able to see my screen. So we'll just look into it. And in the meantime, if anybody has any questions regarding this, I would strongly encourage that you post it in the chat panel, and we will be happy to help you at the end of the session. So I think most of you did not see my screen. So let me just quickly go through what we discussed right now. As I was saying, product design collection provides you with a set of tools which can help you to interconnect your workflows, covering various aspects of engineering, and also provide you with tools and technologies which are cloud enabled and help you prepare for the future. So there's the same thing that we discussed, where product design collection provides you a platform to create a very, very tight integrated digital prototyping model, which can help you to start your design right at the concept stage and all the other auxiliary engineering activities around it, uh, like your detailed engineering. It could be your tubing, piping, sheet metal frames, all the different types of engineering aspects into it, and then go ahead and help you to also automate your design, create layouts for your factory, understand the overall working of the factory, review the entire process of the factory, and finally help you to create documentation, technical publication, as well as marketing material in the form of imagery or videos for your marketing or concept level processes. So as I was saying, the way it does is by providing a very, very tight integrated, interconnected workflows between various platforms. So product design collection comes with a host of different set of solutions, right from your 2D solutions, like 2D mechanical, which caters into the manufacturing or the mechanical engineers. It also comes with AutoCAD Electrical, which caters for all the electrical drafting related works, and also AutoCAD Architecture for all the civil architecture and factory related layout work. It also comes with Inventor, which is a professional grade design tool which can help you not only create only 3D models but also add a lot of design aspects into it. It can help you to interconnect with various third-party CAD solutions, communicate in a better platform in the form of a 3D PDF, or share your design via means of web. It also will help you to do your electromechanical workflows, your layout planning, and also integrate with the cloud services for a seamless collaboration between your vendors, suppliers, customer, whomsoever you are interacting with. So we will start with the mechanical design workflow. So when I say mechanical design workflow, I will not go detail into the modeling aspect of the 3D, which everybody, I presume, is pretty familiar with the 3D modeling aspect of it. But some of the unique functionalities and features which Product Design Collection offers, which can help you to do your work faster, increase your productivity, and leverage your existing data. So one such new technologies that has been added, something called as Inventor AnyCAD. Many of you would have used it or would have heard about Inventor AnyCAD. It's a new kind of a tool and a platform which Inventor provides, which lets you to utilize any of the available 3D CAD solution. It could be your UG, ProE, CATIA, SolidWorks, any of those solutions, without losing any data. So now why I am stressing on this part is we all work with a lot of data which we receive from our customers. So the data could be in the form of a native data, but currently the biggest challenge is none of these technologies talk to each other. The only way they interact is by means of a neutral CAD format, that is either your IGS step or a parasolid file. And everybody who has worked on these files know the pain of working with these kind of neutral files, because they do not contain any data. There are a lot of geometrical inaccuracies, as well as there could be a lot of data that could be lost in the entire process. So that is where Inventor AnyCAD can help you to directly read the data or import the data without any kind of a data loss. So the way it can work is, you can directly integrate with your OEM or your tier 1, tier 2 industries without you having to invest in a very costly solution just because to re just because to read those original data. So with Inventor AnyCAD, I can actually go ahead and use the actual data and then exchange the data and achieve any of these manufacturing workflows using Inventor. So the overall benefits is your overall time to market is reduced, because you are spending very less time on a neutral file format. You are not redoing it, you are not redesigning it, nor you are doing any of the patch-up works. Similarly, you are leveraging your existing CAD system without you having to go for a big migration projects or other things and all. And finally, at the beginning, as Ajit said, with the subscription model, your overall cost of ownership will be next to nothing. So this is how Inventor AnyCAD is positioned, where it can interact with any of these solutions that are currently available in the market without any kind of data loss. If there is a third-party solution, Inventor reads it directly without any kind of a translational data loss or anything. So whatever data you have either in your CATIA, SolidWorks, ProE, or any of those files will be read exactly the way in Inventor, with not only from a geometrical perspective but also from the metadata or the summary properties perspective as well. So it also brings in the metadata part of it as well. So this is the overall workflow of Inventor AnyCAD, where I collect the native CAD data, bring it inside Inventor using AnyCAD. So there is absolutely no data loss, and any change the original model undergoes is automatically updated in my Inventor final assembly. Now, the other part of it is, if you had seen the previous slide, AnyCAD is also been applied, or they have opened up an option to even read the AutoCAD files as well. So one of the reasons why this is very important is most of the organizations has a lot of 2D legacy data that are lying around without it being converted into a 3D platform. Now, as everybody knows, it's not an easy task to convert a 2D file into a 3D file, and there is no automated process that you can go ahead and quickly convert a 2D file into a 3D file. So that is where Inventor AnyCAD, the DWG Underlay option, will give you more freedom, more tools, and more uh, uh, power to you in terms of very quickly converting a 2D file into a 3D file. So I'm just playing a video right now where I'm just bringing in the data from my AutoCAD to my Inventor, which is my 3D. I can switch on and off the different layers that has been created in AutoCAD, go ahead and start selecting those sketches or important areas which I want to project and start creating a 3D out of it. So I go ahead and select all the relevant sketches, go ahead, extrude it, give it some thickness, and go ahead and create a one view of the 2D model. Now I go ahead and place the other view on other side and go ahead and create the other part of that model as well. And I'm utilizing the AutoCAD drawing files here. So that is, so there is a seamless integration between my AutoCAD file and my Inventor 3D model, which I'm creating using my drawing files. So I go ahead and create those model as is the entire final. Go ahead, mirror it, do the normal 3D modeling operations that we do day in and day out. Now the best part here is, as I said, this is completely integrated. Any change that I make in my 2D, let's say I'm changing the hole diameter, I go ahead and save it. It is, if you keep a closer look, it is automatically updated in my 3D as well. So it is not just a way where I'm just selecting some sketches from the drawing file and using it. It is a completely interconnected workflow where any change that I make in my 2D is also reflected in my 3D aspect as well. Now the other part of it is, let's directly jump into the tool itself, where let's say you have a huge assembly with you which is being done in your AutoCAD mechanical. So how do I start my process of creating a 3D out of it and making sure that the overall concept that we have created in my AutoCAD meets all the requirement or not? So I have my drawing file. I go ahead, go to my Inventor, start a new sketch, and there you can see I have an option where I can insert an AutoCAD file. So I will insert that AutoCAD file here. So it asks me a couple of requirements, like what should be the units. Do you want to import any constraints which have been predefined in my AutoCAD mechanical? If you have already predefined, you can directly bring it here, or you can once again go ahead and give the constraints in Inventor itself. As well as it also asks me, do you want to convert the AutoCAD blocks into Inventor blocks? So I say okay and finish it off. It goes ahead and creates the view in my Inventor. So I have the model completely ready, but if you notice, this is still a part file and this is a complete assembly. So how do I create a platform where I can convert all these blocks into an assembly file and then go ahead and start my 2D to 3D conversion? So I go ahead and finish the sketch. Then Inventor has an option where I can create components out of it. Let me just save it first. It asks me to select the sketch, and you can see these are all the different blocks which has been converted from AutoCAD blocks into Inventor blocks. I go ahead, say next and OK. And if you can see here, now it has created an assembly file. So .iam is the assembly file extension for Inventor. So it has created a complete assembly file. So we were talking about the concept part of it. The first concept is to see whether the overall kinematics of this particular linking mechanism works or not, based on the design we had. So it has got a lot of different types of constraint mechanism, which I can go ahead and do it. I can directly go ahead, constrain these two, say apply. Now let me just ground it so that the support system doesn't move. So you can see this is apply. Let me apply another constraint. I'll apply to here. And if you can see here, now it is starting to make sense. I will once again go ahead and apply this. So you can see here, so this can go ahead and I can start seeing some logical conclusions to it. So you can go ahead and complete this entire linking mechanism here. I will just go ahead and show you something that I've already created. So I have my completed file. I go ahead and see what is the extent, whether it is behaving as per my linking and the kinematics that is provided, what is the extension of it, what is the reach, and other things can be very easily and quickly be understood. And previously we also saw that we could create a 3D out of my 2D drawing. So using that technique, now I can go ahead and start creating a 3D out of my 2D and fill it and see how my entire mechanism works, and go ahead and understand the overall workflow for it. So using the DWG underlay, I can then go ahead and start creating a 3D out of my 2D drawings. Or if it is a bought out or a store item, and if I have the 3D model of it, I can directly bring in here and start doing my assembly operations. So now the next important part of any workflow is, let's say we have our design ready. We also need to do at least some level of basic simulation to understand its behavior and its working. So Inventor is also equipped with a validation tool which can help you to very quickly do a lot of different types of simulations, be it your dynamic simulation to understand the different forces that are acting on a particular moving body, to calculate the unknown forces required for a cylinder or an actuator system to actually go ahead and lift something. Or you can go ahead and do a stress level analysis to understand the different types of stresses and the displacement that it undergoes due to the various forces that are being acting on top of it. It also comes with an optimization tool which can help you to quickly create a multiple set of parameters and run it to define which is the best possible solutions, which is the best possible result which meets my technical specification or requirements. And finally, you can also go ahead and do a frame analysis on any of your structural members, where it calculates it as a beam element and very quickly, in a fraction of a second, gives you the best of the results in terms of its bending and in terms of the stresses that are applied at various loading conditions. So one such optimization, let us go ahead and look at that. So let me just quickly copy something here. So let me open an assembly file. So this is one of the connectors, and if you are able to see, there are a lot of welding joints that have been provided based on the calculations and the parameters that have to be defined. So the overall objective of this simulation is to run it through a different parametric table across various dimensions to see which particular set of parameters or which particular set of its form suits my requirement. So it has got an simulation environment. So I will go ahead, create a stress analysis. And as soon as I create a stress analysis, it opens up a new dialog box where it asks, do you want to do a single stress analysis or a parametric dimension analysis tool? So I go ahead and I pre-assign that the contact, because it is welded, I go ahead and say it is all bonded contacts and say OK. And it is very simple to use, where you just have to follow the things which are available in the model tree, right click, and I say show all materials. So it automatically recognizes the materials that have been provided during my design stage itself. So it's made of steel, mild steel and welded mild steel. I go ahead and create my constraints. So I know that these are fixed, but it is not fixed along the axial direction. It is fixed along the radial and the tangential direction. I go ahead and provide the constraints for all the 4 locations. So now if you can see, this is completely constrained across the tangential and the radial direction, but across the axial direction it is free. I go ahead and provide a force. I know that the overall force is around 5,000 newtons. I select all the locations. Wherever it is bolted, I am going ahead and creating the loads. So once this is done, the next thing is, if you see this support member, I want to run a simulation with multiple thickness of this support member and find out which possible or which is the best thickness where it meets my technical criteria. So I go ahead and create a parametric table. And the beauty of today's 3D modeling solutions are its parametric nature, where I can go ahead and drive the different parameters without even entering my sketching environment. So I say that this is my driving dimension. I say go ahead and OK. So this is where you can see it has fixed that this is my driving dimension. I will add couple of more dimensions to it. Let's say 14 mm, 16 mm, 18 mm and 20 mm, and right click and say generate all configurations. So it goes ahead and creates different configurations. So now if I just zoom in, and I hope you are able to see it, if I just make it as 20, you can see it has automatically updated the thickness for it with all the other constraints from 14 mm till 20 mm. Now the next thing is, what are all the design constraints that we have to choose? So I go ahead, right click and add a new design constraint. Let's say first I will add the mass. Next I'll say factor of safety and 1 measure stresses. I can add multiple such constraints. There is no limit as to how many such constraints have to be given. I go ahead, expand the table so it is quite visible for everybody. I go ahead and then create automatic contacts where it will automatically understand where the contacts are and start positioning. So you can see, this is the contact between various elements here. And then go ahead and simulate it. If I want, I can go ahead and play around with the mesh depending on the kind of results that you are looking for. So I quickly run the simulation. So it has to run for 4 different set of parameters. And as you can see, it is already halfway through the simulation. It gives me very, very, very quick results in a matter of minutes, which I can go ahead and start using it to very quickly validate my design, either for my stress analysis or for frames or any kind of different types of analysis that we discussed earlier. So it goes ahead and gives me the solution. So you can see here, let me just keep it as adjusted. So it says that for 20 mm, the von Mises stresses are 134, and if I see the displacement, it's around 0.3285. So right now we have just defined the design constraints, but we have not given any kind of a constraint type. So let me just say that use minimize for mass. So what it means is give the lowest value of mass which will meet the requirement. Similarly, for factor of safety, I'll say lower limit, let it be 1.5. It's usually more than 2, but for this sake, I'll just give it as 1.5. So you can see as soon as I type, it is automatically adjusted to whichever is the best possible solution. And finally, let's say the upper limit for von Mises stress is maybe 150. And if you see the results tab, it is giving me that the dimension with 20 mm is a solution that fits my criteria. And if I go to my other, it says that it fits the criteria for mass, but for the other two, it does not fit the criteria. Similarly so I can go ahead and switch, and I can very easily go ahead and find out and optimize my design within matter of minutes to understand which is the best possible solution that can help me to very quickly give me the actual design of the model. And then I can go ahead and animate, and all those things can be done very easily, very quickly, which can then be captured either in the form of a report, which is a Word document, or a HTML format, and use it for our review purpose with the management or with the customer or whomsoever you are interacting with. So I hope this was pretty clear as to how we can very easily go ahead and set up a parametric optimization to understand the behavior of the model under various design constraints as well as dimensional constraints as well. Now this is till now what we have seen is on the mechanical design workflow. We also have our product design collection also comes with electrical design workflow, which can be used to very quickly work with Inventor and AutoCAD electrical to seamlessly design your electrical and mechanical components in a simultaneous manner, which can help me to create wire harnessing, create the nail board diagram, and find out the actual length of the wire. Now, one of the biggest roadblocks in any electromechanical integration is if you are doing electrical drafting, everything is done by means of a line, But when it comes to the actual installation of those wires in the machine, it never goes in a proper line. You have to actually take care of a lot of things, like is it passing near a very hot element? Are there any kind of very sensitive sensors? Or is space available for the wires to pass through different components or sub-assemblies? So this is very, very difficult to achieve. So what happens is you would never be able to get the actual length of the wire. So whatever length, the wire length which your 2D drafting solution throws, you have to go ahead and procure that length of the wire itself. But with this kind of electromechanical design, you can actually go ahead and create the actual length of the wire, and then maybe add 5%, 6% more to that wire and go ahead for your procurement. So this also helps not only in terms of getting you the actual wire length, but also in terms of inventory management, as well as reduction in your overall procurement as well. So AutoCAD Electrical, as I said, is a completely automated 2D electrical drafting solution which can help you to create control panels, different PLC diagrams, create your entire wire diagrams, and using that as an input, I can bring it back to my Inventor and create my wiring diagrams. So let us just take a look how this will work. So I have one of the vehicle which is used to carry lot of load, usually your tree logs or wooden logs. So now any vehicle, any machine nowadays is completely mechatronics or electromechanical in nature. So there are a lot of electrical and electronic assemblies that are also part of your mechanical elements that define that particular assembly. So how do we actually provide a platform to integrate both these solutions so that they are able to talk to each other in a seamless manner? So let me just go ahead and highlight the region where you have your electrical elements. So I have a lot of connectors, wires, and pins. So these pins are connected to, I don't know whether it is visible or not, connected to this particular electronic control unit. But right now, if you see, there are no wires that are connecting there. And it is not an easy thing to actually go ahead and create a wiring connection in any of the 3D solution. But with this electromechanical workflows, whatever data that I have already created in my 2D can be integrated into my 3D. So what I'll do is I will go ahead and extract the properties. Before that, let me just check the different harness properties that it has. So this pin is called as P2, and the bottom pin is, it is not named, so let me name it as P1. It goes ahead and updates the entire model. And then let me just go ahead and locate my electronic control unit, and it is called as ECU1. So now with this in picture, what I'll do is I will just export this data as an XML file. Go ahead. I will save it. Now I will go to my AutoCAD Electrical. I will choose any of the template that I have created and read this data, whatever we had created, the XML file, to create my components or my pins. So I will select pin 1, insert. I will insert somewhere here. I will insert the second pin, and finally my control unit go ahead and place it like this. So now you can see this is the data that we have achieved from Inventor. It is read inside my AutoCAD electrical. Now the next thing that I need to do is wire between various pins. So I'll go ahead and wire it. We need to choose different types of wires. So it comes with a predefined different set of wires, as well as you can create your own different types of wires. I'll go ahead, select this, select. For the next wire, I will select something different, a black wire with 10 American wire gauge. Select here. Now for the pin 2, once again I'll choose a different wire configuration. I'll keep it for pin number 30, and finally a different wire for my pin 8 to pin 4. So I have quickly created some schematic of it. Now if I want to complete this, I can go ahead and bring in the entire data as well and say wire it. So it automatically goes ahead and creates the entire wiring. Now if you notice, there are no, wherever there is a cross between the wires, it is automatically understanding and providing a loop. So AutoCAD Electrical is a very intelligent AutoCAD which comes with a host of electrical data which can help you to quickly create multiple types of electrical schematics needed for your electromechanical integration. Then I'll go ahead and number it, which is very simple. It could be sequential or line reference, and create across the drawing. I go ahead and save this. Go ahead and save it. Let me activate a different and add this particular drawing into a project file. So I go ahead and add this drawing into a project file. Now next thing what we have to do is we have to set up an electromechanical integration where the wires that we have created can be directly read by Inventor. So there is a new functionality that has been added in the latest version where I can create a link. Let me select appropriate location and say OK and say create. Close. Now the next thing that I will do is I'll go to my Inventor. In Inventor also I have this electromechanical link. I will choose the new link that was created. So basically now what I'm trying to do is trying to create an integration between my 2D electrical to my 3D model. So it comes with the location view where I can go ahead and see whether, so you can see all three elements are there. The next thing that I have to do is I just have to go ahead and assign it to those particular assemblies or parts in the assembly. And finally, for my electronic control unit, I go ahead and set this up. So now if you see here, currently there are no wires that are created. I will just right click and say create a connection. what it does is it starts reading the data from my AutoCAD electrical, and appropriately based on the different pin numbers, it automatically goes ahead and creates my entire electrical wiring within my 3D environment. So there are a couple of ways by which I can route it through a different splice. So I also have an option where I can go ahead and automatically route it, where it is intelligent enough to understand which wires have to pass through which different set of cables. Now it is saying it has selected 16 different wires, and go ahead and create a completely wired model which passes through the different segments. So it is automatically understands the segments that are available and automatically routes it. So that is the power of electromechanical integration. So with this integration, now I can go ahead and create a nail board diagram, which is very simple to do. It directly brings in the data. I go ahead, finish my sketch. I can place my different connectors. It goes ahead and places my connectors. I will edit it, and I can go ahead and add dimensions to it, and go ahead and create a fully furnished nail board diagram. I can also make sure that I can get data for all the wires or individual wires in terms of its length, bend radius, categories, the maximum length, the length that is required, and say okay, and it goes ahead and creates the data for me in a very easy manner. So that is the power of electromechanical integration, where very easily and very quickly I can go ahead and utilize the wiring information that is created in my AutoCAD electrical to create the complete routing of the wire within my Inventor assembly. Now similarly, this does not end here. So the possibility of product design collection is vast and immense. It does not end at only mechanical integration or electrical integration. You can do various types of different workflows using product design collections. One such workflow is our factory design workflow. So now whenever your design is done, the next thing to do is going for production. So there are various ways by which I can start my manufacturing workflow. You have to start defining your process. Then you have to start planning your entire layout in terms of its space, in terms of its different equipments and machines that come together within the factory. You go ahead and create a detailed design of it. You review the entire design before it is being built, or you review it before it is retrofitted or redesigned. Then you communicate that intent across different stakeholders, either within the organization or outside your organization. So one such thing is very quickly go ahead and create a layout within AutoCAD where you place different machines, you place the different types of transportation methods, either through conveyors or through some other means. Quickly do some kind of an analysis to understand the flow of materials, the transportation time, and the utilization of individual materials. Then with the beauty of product design collection, it comes with the set of solution called as factory utilities, which can help you to very quickly create a 3D layout out of your 2D layout that you have defined in your AutoCAD architecture or AutoCAD mechanical, where it is completely bidirectional in nature. And then go ahead and do a complete review of the model in my 3D to understand whether there are any clashes, reviews, or just to have a walkthrough of the facility. And finally communicate this data by means of different types of tools and technologies like Navisworks, which can help you to very easily go ahead and communicate that data. On top of it, product design collection also comes with a tool called as recap, which lets you work on your point cloud data. So now what are point cloud data? There are a lot of factories which does not have any proper documentation. So nowadays a lot of customers, what they do is they actually go ahead and scan the entire layout, and the output of that scan comes in terms of your point cloud or in terms of a mesh data. So recap is a tool which is short for reality capture, which lets you to work on those different set of point cloud data, edit it, make it proper, and bring it into any of the other design platform like Inventor or AutoCAD, and go ahead and use it as a platform or a base to either start the design from scratch or do your retrofit design. So what we'll do is we will very quickly take a look at how this can be achieved. So let me just open AutoCAD architecture, which is once again a specific set of AutoCAD which caters to the requirement of architectural needs, civil needs, which is most prominently used in the creating layouts or in the factory management. So what I'll do is, so this is my factory utilities that you get using product design collection. So what factory utilities consists is its interoperability nature with various sets of solution, as well as with a host of library solution which can help you to very quickly go ahead and create your models. So uh, when I say library, so we call it as assets or factory assets. So it consists of vast sets of assets that could be prevalent in any of the factories, right from your architectural, your utilities, different types of conveyors, material handling equipments, different types of processing equipments, different types of machines, robotics, safety equipments, even to the smallest details like a chair or a bin or a fence, to the most complicated of the machines of from different make and manufacturers like Haas, Mazak, and different kinds of process equipment. So you can find a ready made set of data which is already available with us. So what I'll do is I will quickly create some layout, which might have a significance or not, but this is more for understanding purpose. So let me go ahead and bring one more machine here. Let's say I will keep it here like this. What I'll do is I will bring a conveyor from one point and maybe add here, enter. So this is a very small set of things that I have done. Now the beauty here is, if you can see, I can directly, using the factory utilities which comes within product design collection, I can directly connect it to my Inventor, where my 2D is automatically converted to my 3D. Okay, I think the name was already there, so let me just close some things. Which are not required, and then maybe once again open it and sync it back to Inventor. Okay, so there is already a drawing file with that name, so let me create something new with a different file name. I'll bring in a conveyor, save it, save test So now what you are seeing is actually the 2D assets are being automatically converted into a 3D asset, which will help you to very easily transition from a 2D layout into a fully functional 3D layout with all the data and all the information that has been provided in either of the solution is automatically updated to the respective solution. Yeah, so now if you can see here, so whatever test layout that I had created in my AutoCAD architecture is automatically has created an automated 3D model for me without me having to redo things again and again. So imagine the amount of time that I will be saving in terms of recreating my 2D into my 3D. Now, this is not just a one-way process. Now, any other addition that I do, let's say I go ahead and add some fences here. So it is intelligent enough. So, if I zoom in, so there is a rubber band kind of a thing where it automatically understands that it has to go ahead and fix it to that location. Say grounded, I'll add one more. So I hope it is visible for everybody where I have gone ahead and created the new set of fences here. Now if I sync it back again to my AutoCAD architecture, you can see all the information that has been added in my 3D will also get updated in my 2D as well. So imagine the amount of time that you will be saving, where any change that you make in your 2D layout is automatically updated in my 3D and vice versa. So there is no chance of error, and you can choose to work in whichever Yeah, I think it seems it did not. So let me just open it. Yeah, so you can see here it has automatically updated my new layout as well. So that is the power of working with the factory utilities. Similarly, now this is something that very simple that we have worked with. So now let me open something which is a bit more complicated in nature. Let me open an assembly line. I go ahead and I open an complete assembly line here. So what we have done till now is we have created a 2D layout which is automatically updated in my 3D, and in my 3D I can add lot of different details, lot of different assets which are pertaining to my factory. Now as I said, it also has the functionality of reading my point cloud data, which are nothing but data of or a cloud of points, which is an output of a scan machine. So what I have done is I have actually captured the data of all the columns and overhanging objects and created the layout based on the overall structure. So I have created it based on this structure. And as I said, this is not just something, these point cloud data are not just something which are just visible. These are still data where I can go ahead and use it to measure and calculate what is the distance between different components, different between my structure, my columns, across different machines or equipments. Similarly, product design collection also comes with a tool called as Navisworks, which is a very good tool which can be used for your reviewing purpose. So what basically this does is it provides a platform to actually go ahead and review your entire factory. You can actually have a walkthrough of the factory, see if there are any kind of clashes or any kind of interferences that happens between between the various elements in a factory. Go ahead and rectify so that there are no surprises during the installation, commissioning, and the erection of the building or the factory. So now I have the entire factory with me. You can see the same thing is visible in a review environment. I can go ahead and do a walkthrough of the facility. I can see how my machines look like. I can also go ahead and have a complete view of my entire machines, and also I can do a review where I can go ahead and maybe calculate the distance between two machines. It says around 5 meters. I can go around, have a visual input as well. So this is not just the only benefit of using a review tool. What also I can do is quickly do a clash detection. I will add a test and I will say, okay, before that I don't see my point cloud data, so let me just unhide it. So now you can see my point cloud data that is visible here. I will go ahead and do a clash detection between my point clouds and let's say my finishing machine and say run test. So the intelligence of Navisworks is as such that it also understands that the point cloud data is a body and it intersects with one of the machines, and it says that my structure, one of the columns, is actually intersecting with my machine. So it gives me a complete report as to how much data, by how much I would say dimension or how much value it is actually going ahead and intersecting with this. Now what I can do is I can go ahead, let me close it, let me select this, and there is a complete interoperable functionality available with Navisworks where I can directly switch back into my Navisworks, go back into my Inventor model, and it shows me that it is actually intersecting at this location. So this is my point cloud data and this is my machine. So I will right click and just do a simple reposition of it. And go ahead and update the entire file here. Now that is the beauty of using any kind of review tool. So very easily and very quickly I can go ahead, manipulate one platform which automatically gets reflected in my other platform as well. So we were okay. And lastly, you know, for all our maybe for our initial bidding process, or for my technical publications, or for my marketing, we need to create lot of different types of rendering and animations that are required to complete my entire design process. So product design collection also comes with 3ds Max, which is one of the industry's most used tool for all your animations and all your rendering and photorealistic imagery, to capture photorealistic images out of 3ds Max. And 3ds Max has the functionality where it can directly read data from Inventor without any kind of data losses, and I very quickly go ahead and create a animation or very high and high rendered images out of it. So let me just ungroup it. So now I have an inclined conveyor. The overall objective is to move this body in an inclined position across this conveyor. So it comes with a lot of options where I can very quickly go ahead and create animations. I know that, let me just move it here once before I do anything. So this is my move functionality. I have to move only in my X direction. I have to restrict my Z and my Y direction. So I will just go ahead and lock my Y and Z so that I am able to move only in my Y direction. So this is the basic constraining that I have to do. Then go ahead and start creating my animation very quickly. So I have to go to the auto environment, set my key, move this time frame, select this, bring it here and set my key once again. And if I now go ahead and run it, very easily I can go ahead and create these kind of animations at a very quick pace. On top of it, I can also go ahead and very quickly create high rendered images of this, where you get lot of options in the type of rendering engine that you want to use. Either it is ART or NVIDIA Ray or Mental Ray, which is industry's most used rendering engine. I can go ahead and create different types of quality that I want, whether it is a bare minimum, high, or a maximum. One thing you have to keep in mind is, higher the quality of the render, the more time it will take. I can go ahead and see what kind of output size I want. I want a SD video kind of an output, and go ahead and maybe let me just create it as medium for now, or else it will take a lot of time. So you can see it is considering all the reflections, all the shadow, everything, and goes ahead and creates a beautiful render like this. I can actually go ahead and render it for a for the very high end rendering quality, which will take a lot of time. So with this, I can go ahead and create a very realistic kind of images, which can be used for marketing, sales, or even for the initial bidding process as well. I can add environments, I can add animations, create an image file or a video file out of it. So this is, in a very short span of time, we have seen a lot of different types of workflows which we can achieve through product design collections. There are many other workflows as well which we can achieve using product design collections, where we can integrate with the cloud tools that are available with the collection set, which can help you to achieve in terms of collaborations, achieving rendering in the cloud itself. It also comes with a space of 25 GB in cloud, which can be used to which can be used as a storage point as well. So before I end my presentation, I will reiterate what Product Design Collection stands for. It is a tool which provides you with a greater value, more flexibility in terms of tools and technologies, provides you with a different set of choices for your different engineering needs, and very simplistic solution where all these different set of solutions will be provided within a single set of collection. So with product design collection, you will be able to achieve different types of process. You will be able to communicate across different engineering teams, exchange different types of data, and finally you can also integrate with the competitive data or third-party CAD data as well. And finally, it also opens up a lot of different set of solutions which can be used not only from the engineering but also in the marketing and the sales activities as well. So with this, I end my session. I hope it was useful. You are able to learn about how industry collection can be benefit for your organization to achieve various engineering workflows within a single umbrella. Thank you very much. Now we are open to questions. If you have any questions, please feel free to ask.
Hi, Kirti. A couple of questions that we see on the link.
Actually, I'm not able to see the questions.
Can we do multi-body simulations?
What do you mean by multi-body simulations? If it is connected by means of different bodies, yes, I can do multi-body. If you're talking in terms of stress analysis, yes. But if you're talking in terms of multi-body dynamics, then we have a separate set of solution called as Nastran in CAD, which can be used to do your multi-body dynamics.
Okay. How to create 3D dimensional sketch and planes in Inventor? Hello?
Hello? Yeah.
Okay. How to create 3-dimensional sketch and planes in Inventor?
So Inventor comes with a 3D sketching environment where I will be able to create sketches in a 3D plane as well.
Okay. Hi, we are from tool manufacturer. Can Inventor have any module for core cavity splitting?
Yes, so Inventor comes with a module. It is not an extra module or anything. It is a functionality within Inventor itself, which comes with complete functionalities which are required for the tooling industries, right from your creating of the part, core cavity extraction, surface runoff, creating your entire tool body assembly, and automating the entire drawing setup as well. So yes, to directly answer your question, yes, Inventor comes with core cavity extraction as well.
Can we separate two bodies and saved as new part?
Yes, we can do that.
Okay. So, is there any other questions? We know we are overshot our time, but if there are one or two questions more, we can take it. And I will share the recording of the webinar to all of you, so you can refer that as well.
Yeah, before we conclude, I just want to say that Coming 16th March, we are also hosting a webinar which talks about the data management platform that Autodesk provides, that is Vault Professional. So, in a multidisciplinary organization where we have different tools for different set of operations and engineering activities, how do we actually go ahead and manage our data? So Autodesk provides with a platform which can help you to manage, control, secure your entire design data as well as your other set of non-design data as well in a common platform, providing a different set of security controls, administrative privileges, and creating a life cycle for the approval system as well. So I would request everybody to please join this webinar that is being hosted on 16th March from 3 p.m. to 4 p.m., which will give you insight about how data management can be a very, very powerful tool in your organization to improve your productivity, remove duplicacies, and make sure your entire workflow is error-free. I think with this, we will end this session. Thank you very much for spending time with us. If you have any questions, please feel free to contact us and we will be more than happy to help you. Thank you. Have a nice day.
Thanks, Kirti. With this, we come to the end of the webinar. Thank you.